Hello, and welcome to Adding and Subtracting Radical Expressions. All right, the key to adding and subtracting radical expressions is to first you want to simplify each radical term as much as possible, and then combine any like radical terms. So like radical terms have the same root and the same number or variable underneath the radical. Okay, so let's look at this first example here. We have the square root of 8 minus the square root of 32. Now, in this problem, we want to simplify the square root of 8. You can either use a factor tree or rewrite this by using the biggest perfect square that will go into 8, which is 4. So I can write that as 4 times 2. I can rewrite 32 by using the largest perfect square that will go into 32, which is 16. And 16 times 2 is 32. Now I can take the square root of 4, which gives me 2 outside of my radical symbol. I can take the square root of 16, which gives me 4 outside of my radical symbol. Now, since both the 2 and the minus 4 are being multiplied by the square root of 2, I can actually combine those, just like we would combine like terms. So 2 minus 4 would be 2 times the square root of 2. Okay, second problem here, we have 2 times the square root of 2x to the third minus 4x times the square root of 8x. So again, you want to simplify underneath the radical first as much as possible, each one of them, and then you want to combine your like radicals. So 2 times the square root of 2x to the third. Well, neither one of those in there are perfect squares. However, x to the third can be simplified. So since I'm trying to take the square root of it, I want to rewrite this to where it would have an exponent that's divisible by 2. So 2, the next number is smaller than 3, that's divisible by 2, is x squared. So I'll need to rewrite that as x squared times x to the first. And that's still x to the third. Over here, the biggest perfect square that will go into 8 is 4, so I can rewrite that as 4 times 2 times x. Now again, the reason I rewrote those is so I could take the square roots of part of those terms. I can take the square root of x squared, which is just x, so I would have 2 times x outside of my radical and the 2 times x left over on the inside. Now, over here on the right, I could take the square root of 4, which will give me 4 that's already on the outside, times 2, which is the square root of 4, times x, and then 2x left over on the inside of my radical. So simplify that, and I have 2x times the square root of 2x minus 8x times the square root of 2x. Now, since both the 2x and the negative 8x are both being multiplied times the square root of 2x, then I can combine those. 2x minus 8x is negative 6x, all times the square root of 2x. So again, once you get those radicals as fully simplified as possible, if you have the same radical, same index with the same thing underneath the radical, then you can combine the outside numbers. Okay, let's look at a couple more problems. 2 times the square root of 50 minus 3 times the square root of 125 plus the square root of 98. So the square root of 50. 25 is the biggest perfect square, the largest perfect square that will go into 50. So I could rewrite that as 25 times 2. 25 will also go into 125. So I can rewrite that as 25 times 5. And then 98, the largest perfect square that will go into 98 is 49. So I could rewrite that as 49 times 2. Now I can simplify these by taking the square root of 25, which gives me 2 times 5 outside of my radical with the 2 left over on the inside. Taking the square root of 25 again, which gives me minus 3 times 5 with the 5 left over inside my radical. And then taking the square root of 49, which gives me 7 times the square root of 2. So simplify out there, 10 minus 15 plus 7. Now again, if I have like radicals, then I can combine those outside numbers, and you see that the 10 and the 7 are both being multiplied by the square root of 2. So I can say 10 plus 7 is 17 times the square root of 2 minus 15 times the square root of 5. And I cannot combine those two because 17 is being multiplied by the square root of 2. However, the 15 is being multiplied by the square root of 5. All right, and the last problem that we're going to look at in this video is 5y times the square root of 8y minus 2 times the square root of 50 times y to the third. So 8y is not a perfect square, but it does have a perfect square factor of 4. So I'm going to write that as 4 times 2 times y. 50 is not a perfect square. However, it does have a perfect square factor of 25. So I can rewrite that as 25 times 2. Y to the third can also be simplified. Remember, if your exponent is larger than your root or your index, then it can be simplified. 3 is not divisible by 2, so I'm going to the next number that is smaller than 3 that is divisible by 2, which is y squared, and write that as y squared times y. So the square root of 4 is 2. 5y times 2 outside of my radical, 2y left over on the inside. The square root of 25 is 5. And the square root of y squared is y. Again, with 2y left inside my radical. Okay, so simplify on the outside again. So 10y times the square root of 2y minus 10y times the square root of 2y. Well, both of those are being multiplied by the square root of 2y, so I can combine 10y minus 10y, and anything minus itself is 0 times the square root of 2y. And again, 0 times any number is 0. So my final answer here would be 0, nothing. Okay, I hope you found this video to be helpful. Thank you.